I'm Nova.
I'm Alloy, and this is AgentStack Daily.
Today, we are breaking down a Claude Code 3 release hygiene block, Microsoft's MAI coding model family, and an agent infrastructure project radar built for the local coding agent stack. Claude Code 165 landed on June 5 as the latest NPM release, completing a 3-release hygiene block that closed background session gaps, expanded hook extensibility, and fixed Windows path handling for deep temp directory paths. The block adds required minimum version and required maximum version as fleet compliance primitives, extends stop and subagent stop hooks with an additional context return path, and repairs a regression that broke Bazel and EDR-protected Go workflows by restoring correct temp directory behavior. OpenClaw 6.1, Hermes 15.2, and Codex 135 hold their EP063 positions as stable harness lines. The flagship model drop is MAI Code 1 Flash, Microsoft's 5 billion parameter coding model trained on GitHub Copilot production harnesses, scoring 51% on SWBench Pro with 60% fewer solution tokens than comparable models. MAI Image 2.5 hits 1403 on the Arena Image Edit leaderboard. NVIDIA's Cosmos 3 opens physical AI development with an open foundation model in 3 sizes, and the Project Radar covers agent memory, code graphs, and MCP tooling that serve the local coding agent stack.
The harness layer leads because that is where agent reliability gets built or broken. Background sessions have to resume cleanly, hooks have to extend turns without error labeling, fleet version compliance has to be enforceable, and Windows environments have to handle OneDrive attributes and deep paths correctly. Those are the unsexy problems that determine whether operators trust long-running agent work. The model lane gets interesting. Microsoft trained a coding model on its own production harnesses, not public benchmarks, and the efficiency numbers are unlike anything the agent stack has seen from a sub-10B model. The Project Radar surfaces tools that make local stacks less fragile. Let us start there.
3 layers are moving at once, and the most useful way to listen is to keep them separate. The harness layer is the foundation that makes agent work repeatable. The model layer is what determines the quality of what the agent produces. The tooling layer is what makes the whole stack less fragile as it scales.
Claude Code 165 is the headline harness release, completing a 3-release block from 162 to 165. The progression is not a feature wave. It is a quality pass that closes gaps operators discover when a workflow goes wrong. Background sessions that lose running tasks on reattach. Deep temp directory paths that silently break cross-session messaging. Windows OneDrive read-only attributes that cause bash commands to fail unpredictably. These are the failures that make teams distrust agent runs, and they are exactly the failures this block addresses.
OpenClaw 6.1, Hermes 15.2, and Codex 135 are stable this cycle. That stability is itself a signal. The harness ecosystem is maturing to the point where 3 consecutive tools can hold their positions without a regression or a critical fix landing between episodes. For operators who manage fleet compliance, that predictability is valuable. You can reason about your stack without worrying that the next NPM publish will introduce a session recovery bug or a plugin hook regression.
The model lane is where things get interesting for a different reason. Microsoft dropped a 7-model MAI family at Build 2026, and the headline model for the agent stack is MAI Code 1 Flash. A 5 billion parameter coding model trained on GitHub Copilot production harnesses, not benchmark datasets. That is a meaningfully different training philosophy than what most labs have been shipping, and the efficiency numbers suggest the approach works.
MAI Image 2.5 puts Microsoft ahead of Gemini on the Arena Image Edit leaderboard for the first time in a while, which matters for Microsoft integrated stacks that need image tasks inside the Copilot surface. NVIDIA's Cosmos 3 is the open physical AI foundation model that robotics teams and simulation-based development shops will build on. And the Project Radar covers 3 tools that make local coding agent stacks less fragile: Understand Anything for code graph navigation, Agent Memory for shared cross-agent recall, and MCP Jungle for MCP server sprawl management.
The order is deliberate. Harness first because that is where trust gets built. Model second because that is where capability gets defined. tooling third because that is where the stack gets easier to operate.
Claude Code 165 is the June 5 NPM latest, completing a 3-release block from the EP063 baseline of 162. The block is not a feature wave. It is the kind of release that closes gaps operators discover when a workflow goes wrong, and it is worth understanding each fix individually because they touch exactly the surfaces that make agents trustworthy in production.
Version 163 is the most operationally interesting of the three. Required minimum version and required maximum version are managed settings that let org admins enforce version gates. Claude Code refuses to start if its version falls outside the allowed range and directs the user to an approved version. For fleet operators who need deterministic behavior across versions, this is a real compliance primitive. You can now lock a team to a tested version range and know that nobody is running a version with a regression or a missing feature you depend on.
The plugin list command now shows installed plugins, and you can filter by enabled or disabled. That matters when plugin sprawl makes it hard to audit what is actually loaded. If you have 5 plugins installed and 2 are disabled, you need to know that before you debug a hook failure or a tool call issue. The filter flags make that audit straightforward instead of requiring you to read through a full plugin manifest.
Stop and sub-agent stop hooks can now return what the team calls additional context. The hook can give Claude feedback and keep the turn going without being labeled a hook error. That changes how hook authors can extend a session. A hook that needs to surface information without blocking the turn now has a clean contract. Before this, a hook that wanted to provide context had to either block the turn or return an error, which both stopped the run and confused the operator about what happened. The additional context return path separates those concerns.
Skills get a small escape syntax tweak for shell variables, so command bodies can pass them through without the harness misreading them. That is the kind of fix most listeners will never see, but it removes a class of confusing skill load errors.
Stio MCP servers now receive the same Claude Code session ID as hooks and bash do when you resume a session. This closes a gap where MCP servers could not correlate a session across resume operations. If you resume a session and an MCP server needs to know which session it is talking to, it now has the same session ID available that hooks and bash receive. That makes session-aware MCP tooling more reliable.
The Windows fixes are worth noting individually. A regression in 154 caused the harness to override the temp directory for all bash commands, not just sandboxed ones. That broke Bazel and EDR-protected Go workflows that depend on the actual temp directory. Bazel uses the temp directory for build artifact caching, and EDR tools monitor process creation and file access against the real temp path. When the harness overrode the temp directory for all commands, those workflows stopped working correctly. Bash commands now fail correctly on Windows when the session-env directory has the read-only attribute or lives inside OneDrive. Cross-session messaging also silently broke when the temp directory pointed at a deep-nested path. That is now fixed.
Version 165 is pure bug fixes and reliability improvements. The practical signal for fleet operators: audit your version compliance settings and set required minimum version and required maximum version if you enforce version gates. Run the plugin list command with the new filter flags to see what is actually installed. If you have hooks that need to extend turns without error labeling, test one that returns the additional context field. And verify that Bazel and EDR protected workflows run correctly now that the temp directory regression is fixed.
The 3-point release cadence in a week sounds like noise, but the fixes touch exactly the workflows that make operators say I did not know that could break. Background sessions, deep paths, Windows OneDrive, and fleet version compliance. Those are the unsexy problems that determine whether you trust a long-running agent work session, and they are exactly the problems this block closes.
OpenClaw 6.1, Hermes 15.2, and Codex 135 hold their EP063 positions as stable harness lines. No new stable releases landed this cycle, which means the operational guidance from last episode still applies. That stability is worth acknowledging because it is not guaranteed. The harness ecosystem is still young enough that regressions land between episodes, and the fact that 3 consecutive tools can hold their positions without a critical fix is a signal about where the maturity curve is.
OpenClaw 6.1 remains the coordination and governance surface that turned a Kanban into a multi-agent orchestration surface. Workboard is the headline capability. Task-backed board runs with task comments embedded in the edit modal, which matters because review stops decaying when it is embedded next to the work. Skill Workshop is the governed path for agent-authored skills, with apply, reject, and quarantine flows plus rollback metadata. SQLite-backed recovery handles iMessage state and the plugin install ledger, so restarts recover without duplicate file system scanning. Bounded timers and retries wrap provider and plugin request paths, so OAuth, device codes, media downloads, and generated content polling all fail cleanly instead of hanging a run indefinitely.
Hermes 15.2 remains the stable multi-agent Kanban line with worktree isolation, swarm coordination, and promptware defense. The worktree isolation is the key architectural decision for parallel agent work: no branch conflicts, no manual branch management, no session interference when 2 agents operate on the same codebase at the same time. Swarm coordination adds the primitives for multi-agent task distribution, and promptware defense guards against model instruction drift in long-running orchestration scenarios.
Codex 135 remains the OpenAI CLI with clearer TUI diagnostics, tightened app server lifecycle handling, named hooks with permission scopes, and improved Python and Node SDK behavior around threads, turns, and error propagation. The diagnostics improvements give operators evidence instead of forcing reconstruction from scrollback and logs. The named hooks with permission scopes make it easier to audit what each hook can do before it runs, which matters for security-conscious deployments.
The practical signal for operators is that these stable lines are tested. If you are running OpenClaw 6.1, Hermes 15.2, or Codex 135, the capabilities and reliability characteristics have been validated across multiple episodes of production use. The upgrade calculus is different when a tool is stable versus when it is in active development. Stable tools get upgraded for security patches and critical bug fixes. Development tools get upgraded for new capabilities. These 3 are in the stable category, which means the upgrade decision is lower stakes and more predictable.
For teams tracking CLI packages, Claude Code 165 is the one that moved this cycle. The others are in position.
Microsoft opened Build 2026 on June 2 with a 7-model MAI family announcement. The model that matters most for the AgentStack is MAI Code 1 Flash, a 5 billion parameter coding model trained directly on GitHub Copilot production tool harnesses, not on generic benchmark datasets. The training approach is the key differentiator, and it is worth understanding why it produces such different results than benchmark-trained models.
By training on the same harnesses developers use for their everyday coding tasks, MAI Code 1 Flash learns how to interact with surrounding tools and systems in agentic coding workflows. It is not learning how to answer a benchmark prompt. It is learning how to operate in the same environment that production developers operate in, with the same tool calls, the same context windows, the same token budgets, and the same failure modes. That is a fundamentally different training signal than what most labs use, and the efficiency numbers suggest it produces a model that is better suited for real coding work.
The benchmark numbers are concrete. MAI Code 1 Flash scores 51% on SWE Bench Pro, which is a 16-point lead over Claude Haiku 4.5 on the same production harness. On SWE Bench Verified, SWE Bench Multilingual, and Terminal Bench 2, it outperforms Haiku 4.5 across all 4 core coding benchmarks. Those are not cherry-picked comparisons. They are the same harness, the same evaluation protocol, and a meaningful gap in performance.
The adaptive solution length control is the efficiency mechanism that drives the 60% token reduction. The model stays concise on simple requests and allocates more reasoning budget on harder problems. Simple requests get short, direct responses. Complex requests get the full reasoning treatment. The model is not spending tokens on reasoning traces for problems that do not need them, which is why Microsoft sees 60% fewer solution tokens on complex tasks. That translates to lower latency, lower cost, and smoother interactive workflows.
For AgentStack operators, the strategic signal is that Microsoft is reducing OpenAI dependency and competing on foundation model capabilities with training pipelines tuned to its own developer stack. MAI Code 1 Flash is already inside GitHub Copilot and VS Code, which means it is already in the workflows of millions of developers who use those tools daily. The model is not a research preview. It is a production service that developers are using right now.
The MAI family strategy matters for model routing in Microsoft-aligned stacks. If you are already inside the Copilot ecosystem, you can route coding tasks to MAI Code 1 Flash and get better benchmark performance than Haiku-class models with 60% fewer tokens. That is a different cost and latency profile than what you get from models trained on public benchmarks, and it changes the economics of running coding agents at scale.
MAI Thinking 1 is in private preview on Microsoft Foundry, positioned against Claude Opus 4.6 on SWE Bench Pro. The 35B active parameter count with approximately 1 trillion total parameters is a different architecture than the 5B coding model. It is a reasoning model, not a coding model, and it is not yet available for general use. The private preview means builders cannot yet evaluate it against their own workloads, which limits its immediate impact on the agent stack. Watch for GA announcements, but for now the actionable model is MAI Code 1 Flash.
The practical move for agents inside Microsoft Shops: test MAI Code 1 Flash through GitHub Copilot on one real coding task and compare token usage against your previous model. The efficiency story is real, and the benchmark performance is backed by production harness evaluation, not synthetic bench setups. If you are evaluating models for an agent stack, pull the MAI Code 1 Flash benchmarks from Microsoft's production harness and compare against Haiku class and Opus class baselines on your own repo tasks. MAI Image 2.5 scored 1403 on the Arena Image Edit leaderboard as of June 2nd, ahead of Gemini 3 Pro Image Preview 2K at 1388. That is a real leaderboard position for Microsoft in multimodal image editing, and it is worth understanding what the leaderboard measures and what it does not guarantee for real-world agent workflows.
The Arena Image Edit leaderboard focuses on image-to-image editing tasks, not text-to-image generation. The distinction matters because different models are optimized for different use cases. Text-to-image models like DALL-E and Midjourney are optimized for generating images from scratch. Image-to-image editing models are optimized for modifying existing images, adjusting composition, fixing artifacts, adding elements, changing style. MAI Image 2.5 is in the editing category, which is why it competes directly with Gemini 3 Pro on the same leaderboard.
The 15-point lead over Gemini 3 Pro is meaningful, but leaderboard scores do not tell the whole story for agent workflows. The Arena score reflects performance on specific benchmark tasks that the leaderboard curators designed. Real-world agent image workflows include documentation screenshots, UI mockups, diagram generation, and annotation tasks that may or may not map cleanly to the benchmark tasks. The leaderboard position is evidence that the model is capable, but it is not a guarantee of performance on your specific use case.
For agent stacks inside Microsoft Shops, the strategic value is closing a gap where image tasks had to route outside the Copilot surface. Before MAI Image 2.5, a coding agent that needed to generate a UI mockup or annotate a screenshot had to call an external image service. Now that capability is inside the same surface the agent already uses for coding tasks. That reduces the number of external dependencies in the agent workflow, which simplifies routing, reduces latency, and improves reliability.
The AgentStack angle is not about replacing Midjourney or DALL-E for creative work. It is about whether Microsoft integrated agent workflows can now use MAI Image for documentation, UI mockups, diagram generation, and screenshot annotation without leaving the Copilot surface. For OpenClaw, Codex, and Claude code operators who work inside Microsoft Shops, this closes a gap where image tasks had to route outside the stack.
The practical move: if you run agents inside a Microsoft-aligned stack, test MAI Image 2.5 through Copilot or Foundry on one image editing task. Generate a UI mockup, annotate a screenshot, or create a diagram. Compare the output quality and latency against your current image tool. The leaderboard position suggests the model is competitive, but your workflow is the real evaluation.
NVIDIA launched Cosmos 3 at Computex 2026 as an open-world foundation model for physical AI. The model combines vision reasoning, world generation, and action prediction in a single mixture of transformers architecture. That is, three capabilities that were previously separate systems, unified in one model. Understanding why that unification matters requires a brief tour of what physical AI actually means for agent development.
Physical AI is the category of AI systems that interact with the physical world: robots, autonomous vehicles, simulation environments, and real-world sensing and actuation. These systems need to see the world, understand how the world changes, and predict what actions will produce desired outcomes. Previously, those three capabilities required three separate models or systems. Cosmos 3 puts them in one architecture, which simplifies training pipelines and enables end-to-end optimization across all three capabilities simultaneously.
Three sizes are available. Cosmos 3 Nano is 16 billion parameters, optimized for workstation-grade RTX PRO 6000 GPUs. Cosmos 3 Super is 64 billion parameters, targeting data center Hopper and Blackwell GPUs for large-scale synthetic data generation. Cosmos 3 Edge is forthcoming, designed for real-time edge inference. The size tiers map to deployment scenarios, local development and testing on Nano, large-scale training and data generation on Super, and production edge deployment on Edge.
Cosmos 3 is open for research and commercial use. NVIDIA has released the model weights, training scripts, deployment tools, and datasets on Hugging Face and GitHub. That is a meaningfully open release, not a gated API. Teams that want to fine-tune on their own physical AI data can download the weights and training scripts and run the training pipeline on their own infrastructure. The open release lowers the barrier for robotics teams, autonomous vehicle developers, and simulation-based development shops to build on a state-of-the-art foundation model.
The benchmark coverage is broad. Cosmos 3 leads on artificial analysis, physics IQ, PAI Bench, R-Bench for world generation accuracy, RoboLab and RoboArena for action policy, and VantageBench and TAR for vision understanding. Among open models, Cosmos 3 leads on these benchmarks. The benchmark portfolio reflects the three-part architecture: physics reasoning, world generation, and action prediction are all evaluated separately and together.
The AgentStack angle is not immediate coding work. The model is not designed for code generation or documentation tasks. It is designed for robotics, simulation, and physical world interaction. But understanding what physical AI foundation models mean for the next generation of agent hardware is relevant for operators who are watching the horizon. Agents that interact with robots, vehicles, and real-world environments need exactly the capabilities Cosmos 3 combines: vision reasoning, world simulation, and action prediction.
For operators watching the horizon, Cosmos 3 is the open foundation model that robotics teams and simulation-based development shops will build on. The edge size tier is worth tracking for future edge agent hardware, where real-time inference on physical world models becomes the deployment target. If you work on robotics, autonomous vehicles, or simulation-based agent training, pull the Cosmos 3 model from Hugging Face and run it against your physical AI benchmark suite. For general AgentStack listeners, the practical move is understanding what physical AI foundation models mean for edge agent hardware in 12 to 18 months. GitHub's new desktop application is the product announcement that turns Copilot from a reactive coding assistant into a proactive multi-agent orchestration surface. The application launched at Build 2026 in technical preview for Copilot Pro, Pro Plus, Max, Business, and Enterprise subscribers on Windows 11, Windows 11 on ARM, Mac, and Linux. Understanding what it actually does requires looking at the architectural decisions underneath the marketing.
The MAI work dashboard monitors and directs multiple AI agents simultaneously across repositories, issues, pull requests, and background automations. That is the orchestration layer. A developer can see what agents are running, what they are working on, and what state they are in, without switching between terminal windows or chat interfaces. The dashboard is the control center for a multi-agent workflow.
Each session runs in its own isolated Git worktree. That is the key architectural decision for parallel agent work. When two agents operate on the same codebase at the same time, they need to avoid branch conflicts, manual branch management, and session interference. Isolated worktrees solve that problem at the GIT layer. Each agent works in its own worktree, which means the agents can run in parallel without coordinating on branch state. When an agent completes its work, the changes can be merged through the normal GIT workflow.
Canvases are the most novel interaction design in the application. They are interactive, two-way visual surfaces where developers and agents collaborate in real time. The agent displays its current plan, terminal outputs, deployments, or browser sessions on the canvas. The developer can inspect, steer, and verify the work without switching windows. That is a different model from the terminal AgentStack pattern most agents use today. The canvas surface makes the agent's work visible and editable in a way that terminal output does not.
Agent merge automates the pull request lifecycle from picking up an issue through review, checks, and merging. The automation covers the full PR lifecycle, not just the generation step. That means an agent can pick up an issue, write the code, run the tests, handle the review, and merge the PR without manual intervention at each step. For teams that have standardized on GitHub workflows, Agent Merge adds the automation layer that makes multi-agent code review practical.
The Copilot SDK is generally available in 6 languages: Node.js, TypeScript, Python, Go, .NET, Rust, and Java. That means custom tools and agent extensions become a first-class development surface rather than a hack. Teams that want to extend how Copilot agents interact with their existing workflows can build SDK-based tools and distribute them through the normal development channels. The SDK availability changes the calculus for teams that have been building workarounds to integrate Copilot with proprietary systems.
Voice mode in the CLI adds a new input modality for developers who prefer speech to typing. The redesigned Copilot CLI includes voice mode and experimental tabbed access to pull requests, issues, and gists. The voice input is still experimental, but it signals a direction. Agents are adding input modalities beyond text, which matters for accessibility and for workflows where typing is slower than speaking.
The practical signal: if you are a Copilot Pro or Enterprise subscriber, join the technical preview and test one parallel agent session on a low-risk repository. Use the SDK to build one custom tool that extends how an agent interacts with your existing workflow. The isolated worktree architecture makes parallel agent work practical for the first time in a production-quality Copilot surface, and the SDK makes custom tooling a first-class concern rather than an afterthought.
OpenHands brings Kubernetes support and planning mode to autonomous coding agents in its latest release, and it is the most production-hardened autonomous coding agent in the open-source ecosystem. The release shipped in March with 2 major additions: Kubernetes support for containerized agent workloads at scale, and a beta planning mode that adds explicit task decomposition before execution. The enterprise adoption list tells you where autonomous coding agents are on the maturity curve. AMD, Apple, Google, Amazon, Netflix, and Nvidia are using it in production. That is not a research prototype. That is a production tool in some of the most demanding engineering environments.
The agent architecture is worth understanding as a reference point. OpenHands runs in a sandboxed environment with an embedded shell, web browser, code editor, and task planner. It performs end-to-end software engineering tasks, writing and modifying code, running commands, browsing the web, running tests, debugging. The agent does not require you to switch between environments. It operates in the sandbox and uses the embedded tools to complete tasks without external dependencies.
LLM flexibility means you can plug in GPT-4, Claude, Gemini, local models, or others. OpenHands is not tied to a specific model provider. The agent is designed to work with whatever model you provide, which means teams can evaluate different models against their own workloads without changing the agent infrastructure. For teams that have strong opinions about model selection, that flexibility is a primary feature.
The Kubernetes support means OpenHands can now be part of a containerized, orchestrated agent infrastructure. Instead of running the agent as a single process on a single machine, you can deploy it as a containerized workload that scales with Kubernetes primitives. That changes the operational model from run an agent on a dev machine to run agent workloads as a managed service. For teams that already use Kubernetes for their infrastructure, the integration is natural.
Planning mode is the beta feature worth watching. Explicit task decomposition before execution is one of the gaps that separates autonomous agents that work in demos from those that work in production. A demo can show an agent completing a task in one shot. Production work requires the agent to understand the full scope of a task, decompose it into steps, verify each step, and handle failures gracefully. Planning mode adds the decomposition step before execution, which means the agent builds a plan before it starts working.
The enterprise adoption list is the most concrete signal about where autonomous coding agents are in the maturity curve. AMD, Apple, Google, Amazon, Netflix, and NVIDIA are names that carry weight in production engineering. When those organizations are running an autonomous coding agent in production, it means the agent has passed whatever evaluation process those organizations use for production tooling. That is a different bar than passes a benchmark or impresses in a demo.
For the AgentStack, OpenHands is a primary reference for what production autonomous coding looks like. The Kubernetes integration means it can now be part of a containerized, orchestrated agent infrastructure. The planning mode beta is worth watching because explicit decomposition before execution is one of the gaps that separates autonomous agents that work in demos from those that work in production. If you evaluate autonomous coding agents for production use, run OpenHands against one of your repositories and compare its end-to-end task completion against a single-turn coding agent. Test the planning mode beta on a multi-step task and verify whether explicit decomposition improves output quality.
The Project Radar covers 3 tools that make local coding agent stacks less fragile. These are not harness updates or model releases. They are the infrastructure layer that makes the whole stack more navigable as it scales. Understand Anything, Agent Memory, and MCP Jungle each attack a different problem in the local agent workflow.
Understand Anything turns a codebase into an explorable knowledge graph. The tool indexes your repository into a graph database and exposes it through both a CLI and an MCP server. An agent can answer structural questions about the codebase without grepping dozens of files. Questions like what is the request path for this endpoint or which files does this module depend on become graph queries instead of file searches. The knowledge graph gives the agent a navigable mental model of the codebase before it starts working, which reduces the time spent on orientation and reduces the risk of the agent making changes that conflict with existing architecture.
The GitHub API metadata shows 48,000 plus stars and an MIT license, which means the tool is widely used and freely available. The MIT license matters for teams that want to integrate the tool into proprietary workflows without license conflicts. The graph-based approach is different from grep-based search because it captures relationships between code elements, not just the content of individual files. A graph query can answer questions about structure that grep cannot answer without running multiple searches and correlating results.
Agent Memory gives every agent on your machine a shared memory server on port 3111 with confidence scoring, lifecycle management, a knowledge graph, and hybrid search. The shared memory server means multiple agents can access the same memory context, which matters for workflows where one agent sets context that another agent needs. Confidence scoring helps the agent decide how much to trust a memory item. Lifecycle management handles memory persistence and cleanup. The knowledge graph adds relationship awareness to the memory store. Hybrid search combines keyword and semantic search for better recall.
For teams that run multiple agents in parallel or in sequence, shared memory is a capability that changes how agents can coordinate. An agent that completes a task can write its findings to the shared memory server. A subsequent agent can read those findings and build on them without redoing the research. That is a different model from agents that start each session with no memory of previous work.
MCP Jungle addresses MCP server sprawl. As teams add more MCP servers to their agent configuration, the management surface becomes complex. MCP Jungle provides visibility and management tools for the MCP server ecosystem. The tool helps teams understand what servers are installed, what they provide, and how they are configured. For agent operators who have accumulated MCP servers over time, MCP Jungle adds the management layer that makes sprawl manageable.
The common thread across all three tools is reducing fragility in the local agent stack. Understand Anything reduces fragility by giving agents a navigable codebase graph. Agent memory reduces fragility by giving agents shared, durable context. MCP Jungle reduces fragility by giving operators visibility into the MCP server ecosystem. These are not capabilities that make agents smarter in the abstract. They are capabilities that make specific failure modes less likely in production workflows.
The practical cue is what moves from listening to acting. For Claude Code, audit your fleet version compliance settings and set required minimum version and required maximum version if you enforce version gates. Run the plugin list command with the new filter flags to see what is actually installed. Verify that Bazel and EDR protected workflows run correctly after the temp directory regression fix. For Microsoft MAI, test MAI code 1 flash through GitHub Copilot on one real coding task and compare token usage against your previous model. If you are inside a Microsoft shop, test MAI image 2.5 through Copilot on one image editing task.
For NVIDIA Cosmos 3, pull the model from Hugging Face if you work on physical AI or robotics, and track the Cosmos 3 edge size tier for future edge agent hardware. For GitHub Copilot desktop app, join the technical preview if you are a Copilot Pro or Enterprise subscriber and test one parallel agent session on a low-risk repository. Use the SDK to build one custom tool that extends how an agent interacts with your existing workflow. For OpenHands, run it against one of your repositories, test planning mode on a multi-step task, and compare end-to-end task completion against a single-turn coding agent.
For the Project Radar tools, run Understand Anything on a repository with confusing entry points and ask for the request path, then compare the agent plan before and after graph orientation. If you run multiple agents in parallel or in sequence, set up agent memory and verify that shared context improves downstream agent performance. If you have accumulated MCP servers over time, use MCP Jungle to audit what is actually installed and configured.
The thread across today's AgentStack daily is infrastructure maturity. The harness layer is consolidating around stable, reliable surfaces. The model layer is adding new capabilities with production harness training and efficient token usage. The tooling layer is adding the context and management tools that make the whole stack less fragile. The agent stack is getting less mystical and more operational, and that is exactly what it needs to become a production tool rather than a research demo.
The show notes for today's AgentStack Daily are at tobyonfitnesstech.com. You will find the timestamps, the links to the releases and tools we covered, and the deeper technical context that did not fit in the spoken audio. If you want to go deeper on any of the stories, look at the show notes at tobyonfitnesstech.com.
We'll be back soon.
This is AgentStack Daily. I'm Nova. Thanks for listening.